Hello students, in this video we are going to prove a language is not regular using pumping lemma. In the last video we studied about the theoretical part of pumping lemma. So pumping lemma is used to prove that language is not regular. So the theoretical part of pumping lemma, the first step is we have to assume that language A is a regular language. So that is the first step. So we have written assume that A is regular. So what is A? A is given as A to the power n, B to the power n. What is n? N is greater than or equal to 0. So that is the first step. We assume this language is regular. So what is second step? Second step is define a pumping length. So already I told in the previous video, pumping length is a numerical value. It can be any number. So I have taken the number as 7. So but it has to satisfy a condition, that is length of S always greater than or equal to P. So what is S? What is S as per your language? Your language is A to the power n, B to the power n. So your string can be, what is S? Your string S is generated from A. According to the language, it is A to the power n, B to the power n. So what kind of string I will generate from this? So I can substitute the value for n. So that is, if I substitute value for n as 2, I will get a string S as 2A 2B. If I take the value n is equal to 3, then I will get S is equal to A B B. So this is nothing but the string what I derive from the given language. So the pumping length we have assumed as 7. So pumping length is, so now I am going to apply the pumping length here. So that is A, I am going to give the pumping length 7 and B as 7. So that means how many A's? 7 A's, 7 B's. So this number can be of any number. You can take any number as a pumping length. Pumping length is, by applying this number, we will be generating the number of strings from the given language. That is nothing but the pumping length. So now, after that, what is the third step? Third step is, this is the, we got the string. So this is the string. Consider example. We have taken the example because we have taken the value for pumping length is 7. So according to the 7, we have generated the string as this. So now what is the third step? Third step is divide the string S into X, Y, Z. So if you don't understand this concept, you have to see the previous video and then come back to this video. So the third step is, we have to divide the string S into 3 parts, that is X, Y, Z. So now X, Y, Z, we have to divide the string into X, Y, Z. So X and Y and then Z. So there are 3 ways we can divide X, Y, Z. The first way is, the Y is in A part. That is, see now for us, there are 7 A's, 7 B's are there. So how are you going to divide X, Y, Z? That is very important. So I am taking 3 conditions. So first condition is, the Y is in A part. That is, so this 2 A's I am going to consider as X. And then this 4 A's I am going to consider as Y. And these all A and then B, these all I am going to consider as Z. This is one case. Another case, the Y is in B part. So I am going to divide again the string into 3, that is X, Y, Z. But this time I am going to take Y in the B part. That is, these all will be considered as my X. And then B, these values I am going to consider for Y, and this B I am going to consider for Z. the dividing the string into x, y, z part, it is up to you. Anyhow you can divide. Any number of a's you can divide as x part, and then remaining y part and z part you can divide as per your wish. And then case 3 is the y is in the a and the b part. So now here y again I am going to take it 2 a's and 2 b's I am going to consider as y part. And then rest all will be x, and then here the rest all b will be in z. This is how I am dividing the string into 3 parts: x, y, z. So now the fourth step, we are going to the fourth step. Fourth step is x, y to the power I, z. So now what is I? According to the algorithm, we learnt I greater than or equal to 0. So you are going to substitute the value for I. So any value you can substitute, it should be greater than or equal to 0. That is the only condition. So now I am going to consider the value for I as 2. So now if I substitute the value as 2, what will happen? So now x value is, what is x value? X value is, there are 7 a's. 7 a's, 3, 6, 7 a's, and then 7 b's. 7 b's. So now I value is 2. So x is according to case 1. Case 1 is here, the case 1. Case 1 is there are 2 a's for x. So here x remains the same. So 2x I will write like that. But y is what? Y has the power 2. So that is, we have to increase y by 2. So what is y? Y is 4 a's I have considered as y. So this I have to increase it by 2. That means y value, there are 4 a's is there in y value. That I have to double it. So 4 means I have to increase it by 8. So 1, 2, 3, 4, 5, 6, 7, 8. So these 8 a's I will consider as y, because y power 2 is given. And then rest all will comes in z. So a and then all b's. So that is 7 b's will be in z. So now this is when you count a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 a's are there. And then b is 1, 2, 3, 4, 5, 6, 7. 7 b's are there. So now take the second case. Second case is x, y to the power I is z. So that is, what is your case 2? Case 2 is 7 a's, 7 b's. So as per your case 2, what is your case 2? Case 2 is these 4 b's you have considered as y. This a's you have considered as x. So you have taken 6, 7. So these 4 you have considered as y. This is x and this is your z. So now when you x, y to the power I, z. So y I value is 2. X you have to write as it is. So what is x? 1, 2, 3, 4, 5, 6, 7. 7 a's and 2 b's. So you have to write like that. X value you have to write as it is. 1, 2, 3, 4, 5, 6, 7 and then 2 b's. This will be your x. This will be your x. And then y raised to the power I. So what is y? Y is 1, 2, 3, 4 b's. And then the power is I. I value we have taken as 2. So now we have to double the y value. So that means 4 b's you have. 4 b's means it should be 1, 2, 3, 4. Again you have to double it. 1, 2, 3, 4. So 8 B's. These 8 B's are your Y. And then the Z is 1B. So that doesn't have any power. So I am writing as it is. Okay. So now you count total A's and B's. You count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, 7 A's are there, 11 B's are there. So in this you see. Next case, third case. Third case is what? Third case is we have 7 A's, 7 B's. And then what is your third case? Third case is Y is in A and B part. So that is, you have considered your Y as these all will be your X. 1, 2, 3, 4, 5. These will be your Z. So this is what your case 3. You have divided the string S into 3 parts, that is X, Y, Z. So now X I have to write as it is. So I have written 1, 2, 3, 4, 5. And then Y value I have to double it. So that is AABB is given. So AABB, again AABB. This is your Y part. You have increased the Y by 2. Next is B. B is 1, 2, 3, 4, 5 B's. So you are writing as it is 1, 2, 3, 4, 5. So this is your Z. Okay. So now take from case 1. See case 1. Now what is your language? A says A is the number of A's should be followed by the number of B's, and the count of A should be equal to the count of B. So that is what is language A. So whether the condition is satisfied. So that is the string I will get from A. So here whatever string you have generated from A, whether it belongs to A or not, we have to check. So in this case you have generated 11 A's, 7 B's. So which is not in A, because this string according to the given language, number of A's should be equal to number of B's. But how many A's you got? You got 11 A's and 7 B's. So which is not correct, because it should be equal number of A's and equal number of B's. So which is not satisfying the condition. This is not satisfying. So according to the theorem, X, Y to the power I, Z should not be in A. Okay. So it is not in A. And the next one is, here you count the number of A's and B's. So 7 A's and then B's are 11. So now this string also, it is not satisfying the condition. So it's not belongs to A. And the next one is, see this pattern. Here it is, A's always should be followed by B's. But here A's is A and then BB, again AA. So this is not satisfying the condition. And also now we have to see the other two conditions. So first condition, it is not satisfying. Other two conditions also will not be satisfied. That is, the other condition is, according to the theorem, the other condition is length of Y greater than 0. Length of Y is greater than 0. Yes, length of Y is greater than 0. Or it is not less than 0, it is greater than 0. Length of XY less than or equal to P. Length of XY. length of xy is less than or equal to p. Length of xy is, in this length, x length is, what is x length? X length is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus b length is 8. So 9 plus 8 is 9 plus 8. So which is 9 plus 17. It is 17 is less than or equal to p, which is not true. So 17 less than or equal to, what is your p? P is 7. So which is not true. So it is not according to the theorem. It's given as, show that none of these can satisfy all the three pumping conditions at the same time. So these three conditions are not able to satisfy at the same time. So it's a contradiction. So if the language is regular, it has to satisfy the condition, but it is not able to satisfy the conditions. So whatever A's and B's we are getting, it is not the string what we are getting, it is not belong to A. So which is not satisfying the condition. So the other two conditions also it is not satisfying. So because of that, S cannot be pumped, which is a contradiction. So because of that we prove, because here we have taken the language A is a regular. So if the language is regular, it has to satisfy the condition, but here it is not satisfying the condition. So the language is not regular. Thank you.